Okay, so here's one more example of the base 10 Cartesian plane and the base 12 Cartesian plane. The difference between them, I put one on top of the other. So the base 10 here is in red, the base 12 is in black, and you can basically see the lines just aren't adding up. It's only the center points, the middle point here, that share the actual same point. The 1, again, is exactly the same. This is a square with the size of 1 by 1. And what I've got here are two lengths of line, one in red, one in black. So this length of line, the red one, again, base 10, when I put it on here, I'm gonna lay it out like this. You can see it's at a 45-degree angle, so it's in units of square root of 2. And counting across here, we go 1, 2, 3, 4, 5. So this length of line here is 0.5 root 2 in base 10. So now I have this a length of line in black. And so if I put that there, you can see obviously it's shorter, but if I slide it over here and go from there to this point here, again, I'm lining right up on specific lattice points. And I can count again. I'll just try to get this out of the way. So again, we're counting in units of square root of 2. 1, 2, 3, 4, 0.5 again. So this is also 0.5 root 2, but this is in relation to the 1. So the 1 has stayed the same size in base 10. This is what 0.5 root 2 looks like. And in base 12, this is what 0.5 looks like. So you see they're different size lengths. So the 1 stayed the same, but because we divided it up differently, the decimal places are a different size. And the reason I chose 0.5 root 2 is because now I'm going to show you a picture of the dodecagon on a Cartesian plane, but just sitting there without any base. So we can see that this shape exists sort of floating in space, if you want to say it that way, without any particular base. And it's us approaching it in base 10 because we already are in base 10. This is why no one's noticed this pattern, or it doesn't have any significance to us in base 10, because it's basically sat outside of the 1. I'm going to show you it in base 10 and then in base 12, and see how in base 12 it lands very securely on the 1, and the relationship of this pattern to the 1 is extremely important. This is a very foundational pattern. It's just as strong as the triangle, 1, 1, square root of 2, or the special right angle triangle, 1, 2, square root of 3. Those are foundational triangles. So too is this dodecagon, a foundational geometric shape in geometry, in base 12 geometry, and we've missed it because we've been in base 10.